So that makes sense? That was a very symbolic, conceptual question.
Yeah,
Yeah.
it makes sense though.
Cool. Does that help connecting it back to the kinematic?
Yes.
Because this probably looks more familiar than this.
Yeah,
Yeah.
I understand the kinematic one.
Right, it makes you miss the good old days, right?
Yeah. Go back to those.
But yeah, this stuff really is almost exactly the same. So just think of it as, you know, well, what did it look like back in linear kinematics? And then you just swap out your variables for your rotational stuff. Because this and this are exactly the same other than the alpha and the omega. Cool, that was a good one. What does part B say?
I want you to find the angle.
So find the final angle, or theta sub 1, through which the flywheel will have turned during the time it takes for it to accelerate from rest up to angular velocity omega sub 1. Express your answer in terms of omega, alpha, and t. Okay, so thinking back to the linear days, we know that we often defined velocity as change in x over change in time. So if we switch over to our rotational variables, what does that give us?
It would be
Omega.
Omega, good, equals,
Theta over
good,
time over time.
change in theta over change in time. Nice. So again, since we know that delta always means final minus initial, we can say omega equals theta 1 minus theta naught over t1 minus t naught. Since both of these are going to be 0, we can just express it as omega equals theta 1 over t1. But actually,
I think that it says we don't have to use all of them, like for the expressing it or whatever. So wouldn't we just move theta over?
oh, it says we don't
Yeah,
need
it
to
says
use.
just use some or all.
Okay, because yeah, I don't think we're going to need.
The alpha.
Yeah, hopefully it's just. And we want to get, we're expressing theta.
Theta. Yeah.
Theta by itself. Okay. So yeah, it should just be omega times time 1 equals. But I don't know. I don't think I like that. I think we do need to use the alpha. I'm trying to think of how though. Let's think about some of our kinematic equations. So if we have, because this is true if our speed is constant, but our speed's not constant, our speed is increasing because acceleration is present. So we need to take that into account. So if we look at some of our equations, like omega equals omega naught plus a t, that one's not going to be very helpful because even though it's true, it's not giving us theta anywhere. So maybe we'd want to use this guy. It says omega squared equals omega naught squared plus 2 alpha change in theta. And hopefully you recognize that setup from v squared equals v naught squared plus 2a change in x. So same equation, new variables. So let's get theta by itself here. So again, if we swap out this change in theta for theta final minus theta initial, we find out that it's really just theta final. So t sub 1. Because t, or theta naught would have been 0. So to get it by itself, we'd want to subtract that over. So it'd be omega squared minus omega naught squared divide 2 alpha. And since we know that omega naught squared was just, or omega naught was 0, we can simplify it even further and say omega final, or omega 1 in this case, over 2 times alpha.